All right, guys, this is it. Algebra 1, lesson 120. Another year gone, another math class done. After today, obviously, you have to first watch the lesson. So today we're going to do something called geometric probability. I know that your book has a weird name there, but I guarantee you that this is actually way easier than what it sounds, and it is actually easier than I think regular probability, even though I've always told you probability is about counting. So counting. If you don't know how to count, that's a huge problem. Sometimes adding, sometimes subtracting, but most of the times multiplying. That's it. That's all probability is to me. Counting, multiplying mostly, and then sometimes adding or subtracting. And that's it. And so let's actually talk about geometric probability because I'm pretty sure you will like it, especially those of you who know your formulas for area of geometric shapes. More precisely, polygons and circles, because a circle is not a polygon. So let's actually get into the lesson. So in the first example, we have a garden, but the 15 by 10 feet garden, and then a patch of it, 12 by 3 feet, is tomatoes, right? So 36 feet squared is tomatoes, and 150 feet squared is a whole garden. And so what is the probability? Well, it says that there's a bird that is going to land in the garden, and so they say, what is the probability that it lands in the tomatoes? Yeah, exactly that. So then what happens is this. You need to find the probability of this by finding the area. Because it's what is the probability that it goes into this area. So you're supposed to do smaller area over the larger area. That makes sense. Because then it would make mean that it landed here when it could have landed in the whole garden, right? So as I said, how do you find area of a rectangle? Area of a rectangle is base times height of tomatoes over base times height of garden. Yay! So the base times height of the tomatoes is 36 feet squared. And over the whole garden is going to be 150 feet squared. And so the feet squared would actually be canceled out. Why? Because they cancel out. Duh. And then we have 36 over 150. They can actually both be divided by 3. This would be 12. And this would be 50. Duh. And then by 2. And this would be 25. And this would be 6. So 6/25 is a probability. Then obviously you could do the whatever it is, but I would rather you leave it at 6/25. And that would be the probability of it landing in the tomatoes. I told you it was easy. Let's move on. In example 2, we have the same principle, but now we're talking about circles and not rectangles. Rectangles is pretty easy. The only thing that you have to know about circles is the area. The area of a circle is radius times pi. No, pi times radius squared. Sorry. So what we need to know is what is the probability of a dart landing in the center of the target itself. And so we know that this is 12 inches, the radius. So 12 inches is going to be 144 pi. And let's actually not multiply by pi. You will see why. So 144 pi is the area of the whole thing, right? But I want it to go right in the middle. And the radius is 4, which is squared. 4 squared is 16 pi. The reason I don't want to use pi is because they cancel each other out. I don't need inches squared either because they're going to cancel each other out. And the probability would be 16 over 144. Now we have to simplify the probability, which we could also divide by 4. This is going to be 4, and this is going to be 36. And then I'm going to divide by 4, and it would be 1/9. There's a 1/9 probability of a dart hitting the center. And that's it. I'm telling you, this is really easy. So let's move on to the final example for Algebra 1. Hooray us. For this one is called the probability of the complement. So remember, the probability always has to add up to 1. And so 1 is the important number here in probability. And so what we're going to do is we're going to say, what is the probability? Okay, so let's say this is a city, it's a circle. Let's say it's a circle. And it has a 15-mile diameter. And we have a park that is 5 miles, a square park that is 5 miles each side. Now, they're asking us, what is the probability that if it rains, it hits everywhere in the city and not the park? One raindrop, by the way. If one raindrop falls, it's going to hit everywhere in the circle, but not in the park. Obviously, we understand that the circle is bigger than the park, so it has to be a big percentage. So what we need to understand here is that what we're going to do is say, okay, so this particular probability is going to start by doing the opposite. We're going to start with 1 because all probability adds up to 1. So what is the probability of it hitting anywhere in here if it rains? Well, it's going to be 100% or 1, right? It's going to be certain. And then from there, we're going to say, this looks weird. Better. And from 1, we're going to say, well, we're going to subtract this probability, which is going to be side squared over pi radius squared. That's the probability of it hitting the park. And the resulting answer will be the probability of the raindrop hitting everywhere except the park. That makes sense. Everywhere except the park. Look at that. Everywhere except the park. Math makes sense. So the side squared would be 25 square root of, half of 50 is 25, and 25 squared is 625. Pi. Ooh. This makes it a little bit weird. And this is where our handy dandy calculator comes into play. So I'm going to put 25 over 625 times pi. And that gives us a number. And then 1 minus that would be, I think I did it wrong, 625 pi. 25 over that. 1 minus that. Now it makes sense. The probability of that happening is about 0.987, but we're going to do it to the second decimal place, so it's going to be 0.99. It's pretty good probability because it's about 99% or 0.99 that it will hit the city, but not the park. That makes sense because it's just so small. Let's move on to the final example. Hooray! But before that, the last bonus I will ever do. And so this is the last bonus. What I want you to put down, for those of you who are going to comment on this, is the first 5 people that comment down below what your favorite worship song is will get bonus points, 3 bonus points. And for those of you who are too late and want to still get some bonus points, for the first 3 people that put in Google Classroom what your favorite book of the Bible is, you'll get 2 points. Okay? So now let's move on to the final thing that we have to talk about in Algebra 1 before taking all those tests. Yay. And we can end this class without a weird example that they say that they release like air-filled balloons towards a wall that is square, and what is the probability of it hitting everywhere but the triangle, which is the target. I don't get it. How are you going to release a balloon? Release, not throw. Release a balloon and hit the wall. If I ever release a balloon, if it's blown by people with oxygen and nitrogen and carbon dioxide and everything that we have in the atmosphere, it will just drop to the floor. Obviously, it would just like, not immediately. But if it's filled with helium, as soon as you release it, it will go up. But I don't know, whatever. So let's just say that they're throwing something at it. Let's say a ball. How bad, what is the probability of you hitting everything else except the triangle inside? And again, the probability would be 1 minus the probability of hitting the target, which is a triangle. Area of a triangle is base times height divided by 2, and this side squared because a square wall. So the probability will be 1 minus 4 times 3.5, which is going to be 14, I believe, divided by 2 over 49. Then this becomes probability equals 7 over 49. So it's 1 minus 1/7. And the probability is about, I know it's about, it could be just 6/7. Oh, yay. And that would be it. I was trying to complicate it even more than what they were saying. That's it. We're done. Yes, we did it. We did it.